Hello, welcome. Today we're going to talk a little bit about automated deployment of the database. We're going to talk about continuous delivery, we're going to talk about deployment pipelines, and how we can do that in the world of databases. This is my About Me slide. I spend my day working for Redgate. I spend my nights, because I'm a bit of a sucker for punishment and I like learning things, I spend my nights doing my second degree at the Open University. They're my contact details, use them. It's my job to help people get up and running with continuous delivery, trying to work out how to do CI for the databases, source control for the databases, managing their deployments. That's what I'm here for. These are the goals of today's talk. I don't like people who talk over slides with lots of text, so I'm going to give you a chance to read them. The point is basically we're going to talk a little bit about the tools and processes and how we can actually achieve technically what we're going to do. We're going to talk a little bit about the people, because there are some cultural changes that we need to think about if we are going to go down the continuous delivery route, and we're also going to talk about why this is important in the current world of continuous delivery, of the modern world of software development. Before we start talking about continuous delivery, I just want to kind of take a slightly higher look at it. We're going to talk a little bit about application lifecycle management. Application lifecycle management is a kind of understood concept. It's how we manage the process from making a change in development, getting it into production, and supporting it. And there's a whole load of things that happen in between making a dev change and putting it in a production server. There's probably some level of testing, some mechanism for deploying it, some approval gate. A certain number of people need to touch it, the process at various different parts along the way. How that whole process looks like is kind of governed by three things. The first thing is governance. So there are certain rules, certain laws to do with deploying databases, to do with dealing with data, compliance laws, if you're dealing with credit card details, if you're dealing with health records that we just have to obey. There are certain things that need to work for a development team's point of view. They need to be able to build applications, they need to be able to design applications, they need to be able to test applications, and they need to be able to do that in a way that suits the developers. But equally, from an operations point of view, from a DBA point of view, we need to know that that the code is going to work, that I can deploy it safely, that I'm not going to have any problems when I deploy code, and that it's going to live in the long term. Problem is that even though they are the business goals of delivering code, as a business, this is what we have to do. As a team, an IT team, a database team, this is what we are tasked with. You do get a little bit of friction across the pipeline. It's quite common to have a dev team over here and an ops team over here, or a DBA team over here, and to have people bickering over the fence at each other. The dev guys will say the ops guys don't understand the reason why I need to deploy frequently. They're holding everything up. They're holding up the business. How can we possibly succeed and get to market quickly enough while these ops guys are holding us back? Dev guys in the room, show of hands. 4, 5-ish. The ops guys will come right back at them and say, well, the reason I can't do this is because you're trying to put rubbish code on my production server. You're trying to delete all my data. You are trying to break everything. You are trying to tear down everything this company is built on. Because to the ops guy, the production server is the thing that's earning the company money. Your tiny little incremental release is risky, and it's not more important than throwing away the state of affairs in production. So the ops guys are going to come right back at the developers and say, well, you're writing crappy code, and you need to have a more reliable, you need me to come and approve these changes. I'm going to put up firewalls and approval gates and all sorts of stuff to stop you putting that change in production. DBAs in the room? Got a few DBAs as well. Might be having some fisticuffs later, we'll see. But why does this happen? I mean, as a team who are trying to deliver the business goals, it is a business goal that we deliver the updates to the software, because we need to keep in touch with our competition. It's a business goal that we need to look after our database and protect the data, because we can't let that fail. As a team, it is everybody's responsibility to do that. So why do we have this friction? Who has read any book on software development in the last 5 years? I suspect that it probably featured some of these words. The point is that we've worked out that software development is expensive. It takes a long time. It always takes longer than you think it will. And software developers are expensive to hire, and apart from their salaries, you need to get the licensing, you need to get the computers, servers. It's an expensive business. If you can write the code in half the time, you've saved your company a ton of money. What's more, if you can, in the economy of the internet, where the winner takes all, and first past the post wins, you need to be the first to market with whatever your feature is. If your competitor gets there first, then that's bad. You need to be the first person there. And also, we've worked out that if you deploy 2 years worth of work at once, and then you wait 2 years while you do the next bit of work, and then you deploy again, chances are you're probably not going to get it right. If you have smaller, iterative chunks of development, deploy smaller batch sizes, you can get feedback much more quickly, and you can iterate, and you can refine the ideas of what it is you're actually building as you go, and you're more likely to write good software. This is what all the software books, all the books about software development have been telling us. And that's what dev guys think about. Dev guys want to release smaller chunks of code more frequently and faster. The ops guys focus primarily on looking after what's already there, and deployments are risky, right? They go wrong. They care about this stuff. They care about this stuff, that stuff. They care about looking after the database. Why? Because at 3 o'clock in the morning, when it falls over because some pesky developer made a change on the production box, there's a guy that gets called into the office. They have to fix it at that time in the morning. They don't get paid overtime for that, and they still have to be there at 9 o'clock in the morning the next day. That's why they're grumpy. That's why they're not going to let you do it. So while we need to respect the importance of this stuff, of having a reliable database deployment process, we also need to work out how we can do it in a faster way, in a way that suits everybody across the pipeline. People talk about Toyota a lot. People talk about lean as a concept a lot. There are a lot of individually sensible things on this slide that most people wouldn't disagree with. There are a couple that I want to call out in particular. Most importantly, this optimize the whole thing. What you see a lot in development teams is you've got a dev team over here, an ops team over here, possibly a QA team in the middle, and various other people throughout your pipeline. They're each doing things to make their own job a little bit quicker and a little bit faster. The dev guys might cut corners in dev to be able to get that feature out at the expense of the ops guy who has to support it later. The ops guy might put a really awesome system in place to scrutinize every single change that comes through to him, so that he can make sure that his task of keeping the production server up and running is okay. He wants to take 3 weeks over every single deployment just to make sure he gets it exactly right. But that doesn't help the developer. We want to look at the whole solution and try and optimize the whole thing from start to finish. We need to look at it together at a higher level rather than just thinking about it in our individual silo. There's a really good book called The Goal by a couple of people whose names I can't pronounce, but it's on the slide at the end. It talks about, imagine your dev through to production workflow as a pipeline. Now imagine where your constraint is. Where is the thinnest part of your pipeline? The bit where the least oil or water or whatever I'm using in this metaphor can get through. The place that is holding up the code getting through your pipeline. We're going to call that your constraint, your bottleneck. You need to be focusing your efforts on optimizing that bit right there. If you optimize anything after that, it's a waste of time, because the rate at which you can develop code and get it into production is defined by your constraint over here. That constraint may be that you've only got one DBA who can do all the deployment work. It may be that you don't have a build server, so you're doing all your testing manually. It may be that you're not source controlling your code efficiently, so you're endlessly having a communication problem within the developers about which changes going where, and it gets very, very complicated. At the same token, if you do any optimization before your bottleneck, you end up with big stockpiles of changes that just can't get through. And there's actually a cost involved in kind of work in progress, because apart from the fact that you can't get the work through quickly. Also, the people upstream of this bottleneck aren't getting any feedback on the code. They don't know whether it's working or not. So you've got really, really big feedback loops. As database professionals, we do need to take a bit of a hard look at ourselves, because in actual fact, application developers have been speeding up the way they do development faster and faster and faster for the last 20 years or so. They've worked out that they need a way of sharing their changes with each other. They built source control systems. They've worked out that they want to get fast feedback loops, so when they commit a change to source control, they want to know very quickly whether it works okay. They built build servers to carry out automated tests of sorts as soon as I commit to source control, so I know if I've broken anything. They came up with the concept of continuous integration, where stuff works on my machine because I've written the code here, but I've not got the latest code from everybody else. So when I put my code into source control, where everybody else's changes are, I'm going to run my tests on that. Continuously integrating. We're continuously testing the code that as it comes together. And now software developers are coming up with tools like release management tools like Octopus Deploy, Redgate Deployment Manager, release management for Visual Studio, Bamboo. There's loads of them. In the database world, we are still writing software, copying it from one server to another in manual different ways. We don't do unit testing. We don't automate our deployments really. We need to catch up. It's not a good place for us as database professionals to be the ones who are the bottleneck that is holding up the business from releasing. It's really good for us as developers. It gives us a great opportunity to come in and speed this up, because then we're the guys that look good. We're the guys that mean that we can actually release an awful lot faster and a lot more reliably at the same time. But let's think about why we're the bottleneck. First of all, SQL is a messed up language. It is a completely messed up language. It's the only language I know where the guy who deploys it understands the code better than the guy who wrote it in the first place. In application land, I'm pretty sure the developer knows more about C# than the sysadmin that puts it on the production server. In SQL land, the DBA, I'm pretty sure, knows it better than the developer. Database developers will use whatever tool they can to stop writing SQL code. They will use an ORM tool like Entity Framework so that they can write it from the C# layer. They will use a NoSQL database de jure, whether or not it is the right tool for the job, just because it means they don't have to worry about writing SQL, partly because they don't have to deal with that paranoid DBA. The next thing I want to talk about is data persistence. True story, about a year ago I was at a customer site and I asked the DBA there what the data was, where did it come from? And he said, well, it's been in the SQL database for about 5 years. Before that, it spent about 10 years in Access. Before that, it was in an Excel spreadsheet for about 10 years. Before that, it was in a filing cabinet written on paper. Before that, it was on papyrus sheets that we dug out of an Egyptian tomb. The data had lived on for over 1,000 years, probably over 2,000 or 3,000 years. I guess the point I want to make is the bucket that we choose to put the data in is going to change over time. But the data is a higher level concept that we hold dear because we're data professionals and we need to make sure it's maintained in the true sense. Which means we need to think about how we deploy. In the application world, you can tear down and build a new version of the application every time you deploy, but you can't do that in the database world. We've got to think about our upgrade scripts as well as the state of the database at any point in time. So it makes life more complicated for us. We need to think about how to deal with that. And I mean that as a good thing. We should honor that. If I have a database that I'm looking after, if I'm a business owner and I have a database, I probably care about my data because in the modern world it is probably important to me at some level. If the data is important to me, I want somebody to be dotting out those I's and crossing those T's and making sure it's completely okay. What we see too often in development houses is the developers get annoyed with the paranoid DBA. He blocks everything going through. I can't work with this guy. He gets sidelined. People try and circumvent the DBA. No, what we should be doing is talking to the DBA and working out why he's paranoid. What are we doing wrong? How can we avoid these deployments in the future? How can we create a release process that you're happy with? because chances are he actually knows more about SQL than you. He's the guy that's actually going to keep the database safe, the data in the database safe. And as a team, the developers need to work with the DBA and use that knowledge. So work with your DBA on how to do this rather than against him. So taking all that into account, if we're talking about our pipeline, broadly speaking, there are 3 or 4, depending on whether you count those 2 middle ones as the same thing or different things, 3 or 4 main things that we want to look at. And traditionally, we'll start on the left and work our way to the right. First of all, we need to be source controlling our database. It's the most important thing. If we're not source controlling our database, we have no record of what changes are being made and when they're being made. We have no source of truth. We don't know what we're deploying because there is no record of the thing that we're deploying anywhere. Once we start source controlling our database and having a defined state of the database at any point in time, we can start running automated builds. Now, builds is an interesting term when we're thinking about database as opposed to application tier. In application tier, we know what that means. It means taking the written files and turning them into ones and zeros. But for a database, when we're dealing with data persistence, we need to think about what we actually mean there. And then what we mean by continuous integration advanced, and I prefer to use kind of automated builds and automated tests here, is actually using the structure that we're going to build in terms of running automated processes to start building automated tests, to start thinking about how we can test this on an automated basis so we can get good feedback to the developers about whether or not their changes are successful or not. And finally, we can build on top of that a nice automated release process. A word on continuous delivery as opposed to continuous deployment. So continuous integration basically is the first 3 boxes. Continuous delivery, I think of as semi-automatic shotgun, not a fully automatic shotgun. I actually have to pull the trigger to deploy. The idea is that you're always able to deploy to production. It doesn't mean you're always deploying to production. Continuous deployment is the thing where every single time you commit to source control, there's an automated process that puts that straight onto production. That's what Amazon do, it's what Facebook do. It's probably okay for social networks. It's probably not okay for healthcare companies. But the world is moving that way, so who knows what the future holds. But it's important to be aware of that distinction between continuous delivery and continuous deployment. What we're talking about today is continuous deployment. You're probably going to automate the deployment straight out to maybe a couple of test environments, a couple of QA environments, but when you're deploying out to staging and production environments, that's very much a push button thing. Having said that, as soon as you push that button, we want the whole process to be automated as much as possible, because why would you have somebody manually executing scripts in SSMS where they can very easily select the wrong database and everything goes wrong? So let's break these 4 areas down to a little bit more detail. Source control. Who here is source controlling their database? 2 out of more than 2. So when we're source controlling the database, what a lot of people do is they source control their upgrade scripts. So they source control the script to go from V1 to V2, and then they staple onto the end of that script to go from V2 to V3, and then V3 to V4. And then they have a process that runs those scripts automatically. Wonderful. Great. That's not bad. However, an upgrade script is only reliable if you know the exact start state that you're starting from. Let's say the real world happens, and the DBA decides to put an index on production because that doesn't count as a change. Well, now you're running that script on a version of the database that not only is not exactly what you'd expect it to be when you run that script, but additionally, you've ended up with a state on production. By the state, I mean the exact collection of objects and schemas on that database. You've ended up with a state on production that you have never seen before in any of your development or testing efforts. We're all smart guys. We can tell that's probably a bad idea. That's probably a way to run into issues in the future. So what we want to be doing is we want to be source controlling the state at any point in time. In source control, we want to define the state of the database just like we define the state of our source code in our application tier. Now, how we handle our upgrade scripts and our rollback scripts is an important question, but it's a separate question. It may very well be that you want to put your upgrade scripts in source control, probably a sensible thing to do. But the most important thing is that we're source controlling the state of the database in source control, because then we can say with certainty that yes, that version of production is exactly the same as what I've got in source control, and it's exactly the same thing that I've tested throughout my release pipeline. Doing this for greenfield projects is relatively easy because you're starting with nothing. So you build your first table, you put that in source control. It's easy. Starting out from a brownfield project is hard because then you've already got a 13-year-old legacy database that was built in this crazy wacky way because that guy who left 4 years ago thought it was a good idea, and he didn't document it. The best advice I've got for you is hold the line on development, take your production database, restore that, start from that as your development database. Or if you can't restore it, come and clean up the data on it or whatever first. But then at least you know that you're starting from a good starting point that does accurately reflect what's in production. Also, apart from source controlling the schema of the database, there's probably some static data. Things like country codes, a list of countries in your, that doesn't change very often. It does every now and then when South Sudan splits from Sudan, but it doesn't happen very often, and when it does change, we probably want to think quite carefully about how we're changing that. A list of prices on your website, any table that ends in the word type, object type, customer type, address type, they're probably lookup tables, the sorts of data that you want to put in source control because you want to be very conscious about the changes that you make to those tables. What we don't want to put in source control is order history and all the credit card numbers. That's a very bad idea. So what I'm going to do now is I'm going to jump into a demo slightly, and I'm going to show you a tool that Redgate provides to allow you to integrate your database changes, to put your database changes into source control. This is just Management Studio I've got open here. I've got a database here on the left-hand side. And what I'm actually going to do now is I'm going to make a change intentionally that's a bad change that is going to break one of my tests later down the line. I'm not going to talk about why it's going to break that test for the time being, but before you snigger when I make this change, I just want to make you aware that I'm doing this intentionally to break one of my tests. So I've got a stored procedure here. It basically, it's the add contact stored procedure. When I run this stored procedure, I give it a bunch of parameters and it adds those to a database. We've got an email parameter here that we're going to add in with a varchar 30. I'm just going to go ahead and change that to a varchar 10 because nobody's got an email address longer than 10 characters long, right? Let's go ahead and execute that. SQL source control. In this instance, I'm linked to a TFS source control system. I was about to ask what source control systems you use, but you don't. Git, Mercurial, TFS, SVN, Plastic, all of the source control systems. Well, it's pretty easy to link to a source control system. You just select the database on the left that you want to link, go to the Setup tab, link database to source control, and most of the big ones are there. Git, Mercurial, Subversion, TFS are all mentioned.
Do you do this with Oracle?
We do have a separate tool for Oracle, source control for Oracle. It only supports TFS and SVN.
What IDE does that work with?
It doesn't, that's the point. So in SQL Server, we work mainly in Management Studio because that's where most people do their database development. We also support the SSDT folder structure that you use if you're using a database project in Visual Studio most of the time. But that's for SQL Server because basically everybody uses either Management Studio or Visual Studio. In Oracle, there are 3 or 4 different IDEs that people can use. So rather than plugging into any one of them in particular, it's got its own GUI that it uses, and it's kind of separated from the IDE. Anyway, so I am linked to source control. I'm going to go to the commit changes tab while I've got the correct database selected. And we can see, if you're familiar with SQL Compare, which I hope you are because you're in the Redgate office and it's our most popular product, we can see a diff screen here that basically shows us the difference. I've got magnifier on here so I can probably zoom in so you can see. I'm not very good at using this, so I apologize if you all get car sick. But we can see the version on the database versus the version in source control. And I can come up here and hit the commit tab. Actually, let me zoom out quickly. I'm going to go ahead and write a really useful comment. Never type during a demo, it's boring. And I'm going to press commit. That's going to put my code into TFS. I can actually show you it in TFS as soon as this finishes. Oh, by the way, I apologize for the speed of this. I'm running all of this code on a VM on this laptop, and all of the stuff that I've got on here consists of SQL Server, Management Studio, Visual Studio, a TFS server, a TeamCity continuous integration server, Octopus Deploy, which is the release management tool, and all of the Redgate tools. So I am kind of maxing out this VM. In the real world, you'd probably have these on a sensible architecture of servers and things, but let's go with what we've got. So that change is now in source control. So this is how it looked before in TFS. And if I just go to magnifier, we can see down here the varchar 30. And if I just go ahead and refresh this, we're down to a varchar 10. So that's me automating, putting the code into source control in a standardized way that defines the state of my database at any point in time. Going back to Management Studio, I'd like to point out, by the way, that the database is green on the left-hand side. That tells me that this database is linked to a source control repository. It is, in fact, linked to this particular source control repository. And I should have mentioned earlier, there are little blue blobs that appear on the left-hand side in the Object Explorer. The reason application developers find it so easy to source control is because they've spent time building plugins to Visual Studio that allows them to just kind of, that gives them all sorts of ticks and crosses, and it shows them where all the objects are that have been changed or edited, so you don't forget to commit anything to source control. One of the reasons that database developers don't do that is they do their work in Management Studio and they don't have any tools to do that. This is the tool to do that. What we can also do in here, by the way, is we can look at the history. So we can look at the history of all the things that have changed over time. So there's my commit with a sensible commit message. You can tell who has actually made the change. In this example, I'm the Redgate user because this is just a standard VM that we build for all of our demos. And we can see the details about exactly what changed in the code before and afterwards below. Any questions about database source control? Turns out I explained that perfectly. So great, we've got our code in source control. We can look at the history from any version. And by the way, those scripts files that we put in source control, SQL compare can read those. So that means that we can look at the diff between any version and any other version, put whatever filters we want on it, either for a particular object or for the entire database or a particular schema or a particular just to store procedures or anything with this naming convention. We can go from any version to any other version, see a list of all the changes. We can also generate a script to go in either direction. So this is really powerful for generating my upgrade scripts or my rollback scripts. But that's all well and good. We've got our code in source control, but now what? In the application world, once you commit your code to source control, most of the time you're using some sort of build server. That build server could be Jenkins, which is open source, probably the most widely used one in the world. You've also got TFS build if you happen to use all the Microsoft tools. That's built into Visual Studio, which is debatably quite nice. You've also got tools like TeamCity, which is by JetBrains. They're the guys that make ReSharper. That's what we use at Redgate. If you use Jira for bug tracking, Atlassian, who do Jira, also provide a CI tool. It's called Bamboo. And there's actually some quite nice integration between the bug tracking elements and your CI server, which is tracking your builds and monitoring kind of for failures and things. There's some nice integrations there. So there are all sorts of CI tools out there. Redgate doesn't build one. Our advice isn't so much pick any particular one, it's just pick any of them and start using them. CI servers have been around for 10 or 15 years now. They're pretty mature by this period. Whichever one you choose, you're probably better off than you were before. What they do is they automate various scripted out tasks based on various triggers. So my trigger might be I commit to source control, and my task will be I'm going to carry out some sort of testing validation. And then I'm going to feed that back to the developer to say, yep, that was good, or nope, that was bad, go fix. The first and easiest test that we can do is a build. It means we don't need to script out all sorts of complicated tests. We literally build the database and throw it away. And that sounds very, very simple. And why would you want to do that? Well, if you're building it complete from scratch and throwing it away, what we're doing is validating that the SQL that you've put into source control can actually be used to build a database. You could run into problems at this point. Let's say, for example, if you change a table, but forget to change the view that looks at that table, you're going to end up with an invalid reference. If I tried to build that from my scripts in source control, or if I tried to deploy the database to look like that, I would probably get some sort of error. I'd probably get a SQL server complaining, no, you can't do that because that's against the law. So actually, just by building the database from scratch, we're finding out a little bit, possibly within a couple of minutes, about a mistake that we've made. Now, if we're not doing it this way, we might find out about this a week later in QA, or we might find out about it a month later when we try and deploy it to production, or we might find out about it 3 years later when a customer complains about some bug. So finding out about it earlier when I've literally just committed it to source control is a helpful way to help me build quality into my product, into my database. The other thing that might cause a failure at this point is if I've been using source control, somebody might have not made the change on the database, they might have actually made a change directly in source control. Or, I don't know how much you guys know about source control, but some people like to branch and merge and have like a release branch and feature branches and things, and then bring them back together. So you have different trails of development and then all bring them back together at the end. And what a lot of people do at this point to merge stuff back together is they use some sort of merge tool where they can do a line-by-line merge. And on that select statement, if you've managed to forget that comma at the end of all of your columns, you're going to end up with invalid SQL. It's kind of an easy mistake to make, but by doing a complete build, you'll get that feedback in hopefully a couple of minutes that, yeah, you made a mistake, go fix. The other thing that we can do is building the database from scratch is all very well and good. It tells us that the schema is intact, but it doesn't tell us anything about the way that we're going to deploy that database. It doesn't tell us anything about our deployment mechanism. It doesn't tell us anything about whether we're protecting the data within that database. Remember, we care about data persistence. If you do an incremental build, we can start to move that way. So what an incremental build is rather than building a database from scratch and then throwing it away, I'm going to have a persistent database on my server, a real database that anybody can go to and look at that has data on it. And every time I commit to source control, I'm going to update that database to the latest version. A lot of people in the application world probably already have a version of their application that's constantly running and looks like the latest build that the developers have coded against. But so often, the application tier is reliant on the database tier underneath it. There are dependencies between them. So in an ideal world, we probably want to have the database updated to the latest version as well. We can shoot two birds with one stone by always updating that automatically. First of all, the database is always there at the latest version for all the developers or whoever to go ahead and look at. Second of all, we've validated that we can actually deploy the code that we just put into source control. This is relatively easy to do with Redgate tools. If you're already using SQL source control and you already have a CI server, because you probably have application guys at your company who already have one somewhere, it's actually relatively easy to set this up, and I'm going to show you how to do that now. The last thing that we're going to do at this point is we're going to create an artifact that we can use to deploy, a deployment artifact. The reason we're going to do that is sometimes we don't want source control to be the source of our deployments, because, for example, what if I'm deploying to a remote location that can't access my source control? What if I want to put some sort of configuration or deployment metadata in my release artifact that isn't necessarily in source control? We create a deployment artifact because that means that all of our testing and all of our deployment can happen from the same source. Now let's imagine, for example, the old way of doing things. I make a change on a dev database, I deploy that to test, I do some testing, I find some problems, I fix those problems, I deploy it to production where the DBA puts an index on it because that doesn't count as a change. Like I mentioned before, we've now ended up with a concoction of changes on production that we've never seen anywhere in our release pipeline before. And that's a bad idea because we can get errors that we had no idea were going to occur because we never would have found them because we've never seen this collection of objects before. By using the same release artifact every single time we deploy, we can validate that actually the state that we've ended up with on our test server or our staging server or our production server is exactly the same as what the dev guy had on his machine. So when the dev guy says it works on my machine, you can say, well, that's exactly the same code. So it helps you work out where those problems are, and it rules out a lot of potential problems. So let's go ahead and look at how we can do that. So when I check my code into TFS, that would have been automatically picked up, in my build server. I'm just going to go ahead and refresh this. It's already refreshed for me. Now remember how I said when I made that change, I was going to make a change that intentionally would break stuff? I can see here that I've got a failed build because I've got a test that's failed. Something to do with the email in the add contact store procedure. That sounds familiar. But I'm not going to look at that now because that actually comes under the next bit of continuous integration. What I'm going to do, first of all, just for those, is everybody here reasonably familiar with what how CI servers look and what they are? Because for people that have never seen a CI server, this can be a bit of an unfamiliar UI. Just to explain a little bit, we've got 3 discrete scripted out actions: the database action, the web application action, and the simple talk deploy action. This is an action that we've scripted out, and they're executed on some sort of trigger. Specifically in this case, the database step is triggered by a commit to my source control for my database. The web application step is triggered by a commit to the source code for my web application, and simple talk deploy is triggered by either of the above. So we can see here that 7 minutes ago, which is roughly when I made that commit, we had a build. It took 2 minutes. Let's go ahead and click on this, and we can start to investigate. Now, first of all, we can already see that this is something that actually traditionally normally passes. So this is a history of every single time I've run it before. We've got a build number on the left that increments every single time we run this task. So this is the 170th time that we've run it and it failed. But the last 10 or 15 times we ran it, it passed. I can go and configure what this thing actually does on the right hand side. So version control settings, I'm just telling it where my source code is so that it knows where to go looking. Build trigger, well, I'll tell you that's triggered every time I commit to source control. The build step, now this is a juicy bit, this is the thing that we're actually doing. Now you can add a build step. I mean, I've got 3 of them already here, but you can add a build step to do a whole bunch of different things, and different build servers are going to have slightly different build steps that broadly do the same sort of thing as this. So for example, TeamCity comes with quite a lot of different types of things I can do out of the box. I can run a command line call, so that's exactly as if I was just running the command line from the console. I can do an MS build step if I wanted to, just point it at my solution and that'll build it. What I can also do if I buy the Redgate plugin is I can do a Redgate SQL CI build, test, and sync. The build is the complete build that I mentioned before, where you just build everything from scratch and we create the deployment artifact. The sync step is where I do an incremental build. I deploy to a pre-existing database. So if I look at the build steps, what I've got configured here, I've got a build, I do a test, and then I do a sync. So if I look at this build step, I just tell it where my source control is. So all my source code is in the root where I'm deploying to source control. I name the package. Now we use the NuGet format for our packages. For those that don't know, NuGet is basically a fancy zip file. It was developed by Microsoft specifically so that they could deploy their updates to Visual Studio. If you've ever downloaded a Visual Studio plugin, you downloaded a NuGet package. It uses exactly the same compression technology as zip files do, to the extent that you can literally rename the file extension to .zip and extract it as if it were a zip file. And there are all sorts of features in there that are baked into there just so it's nice for deploying. For example, it's aware of what its dependencies are, so it can make sure it downloads the correct dependencies. It's a really nice technology that was built by Microsoft so they could deploy their code, and now release management tools such as Octopus Deploy and Redgate Deployment Manager have started using the same technology so that everybody can use it to deploy their own code. So we're going to name the package, and this, by the way, is in TeamCity is going to have the name simpletalk.database version .0. Whatever the build number is. So we're on build 170 right now. It'll create a package called .170 so that we've got that traceability right from the build in our build server right the way back to the check-in that created that. So the DBAs in the room are now quite thinking, I can track every single change back to the individual developer that actually made that change. So I know who to go and bang on the head. Great. What we need to do is we need to give Team City the location of a SQL server. And I'm actually running a version, we tend to release about once a week, and I'm running a version of this that's a whole week or two out of date, because we can now give you the option of either running this on local DB to build the database and throw it away, or to actually give it credentials to create a DBO database. We need to give it enough creds to build your database from scratch. It is the nature of the beast that if you are using encrypted objects, you do need to give it SA, but this is just on a test server somewhere. That's because you've got encrypted objects. There's nothing that Redgate can do about that. The amount of credentials that you need to give it here are enough credentials to build a database on that server that looks like what you've put in source control. That's literally it. That's all you need to configure. That's 4 or 5 different text fields in the build step. And now every single time I commit to source control, I'm going to trigger a build. I'm also going to point out this third step as well. This is SQL CI sync. What we're going to do is we're going to inherit the same database package. And a bit like before, where I went and built the database, this time I'm just telling it where is the database that I want to keep up to date. So in this case, it's a database that is imaginatively called always up to date with source control. And I can go ahead and have a look at that on my server here, always up to date with source control. This is useful if I wanted to go ahead and every time I commit to source control, automatically keep a database up to date. I could have a little bit of data in that. I could have a little kind of SQL command after that to go ahead and select, just see whether the 5 rows of data that I put in every single table still exist when I do that deployment to make sure I've not blown away the data. In actual fact, the way we do this is we use SQL compare, which gives you warnings if it's ever going to do anything that is going to drop data, such as dropping a column or dropping a table. And it considers that a high-level warning because we don't want to be responsible for dropping your data. And so that would actually, by default, fail the build, because it would say the thing you just wanted to do is going to cost data. So think about that and try again. If you really, really do want to drop that table, then you can go ahead and change the default behavior of SQL compare to allow it. But by default, we're going to stop that happening because we think you probably want us to stop that happening most of the time. What I'm going to do now, actually no, I'm going to leave it there for the time being. So that was how I configured the automated build, and I can see that it has run because if I come back to the dashboard, I can see that this build did run. It was triggered by a source control commit by the user Redgate, which is me. Here's the source control comment. This is the file I changed, and I've got all the reasons about why it failed here. Any questions before I move on to continuous integration advanced? Okay. So let's jump back to the slides. So it's all very good. We're now beginning to get into quite a nice place. We're source controlling our data, our changes, so that we know we've got a complete audit trail of all the changes that have happened. We now know that, for example, if I get an error report coming in and this particular object, I can now look at the history for that particular object and see what changes have happened to it, who's changed it, why have they changed it. Let's get them in the room and talk about why it happened. I'm now deploying my changes from a known source, and I'm using a release artifact. I'm creating a release artifact, which now means that I can automate deployments and testing of that specific state of that database. And this can all be automated so far. So we're in a pretty good place. But now let's think about testing. I'm going to hazard a guess that nobody in this room full of database professionals actually has a complete code unit test coverage across their entire SQL database. If anybody does, please throw stuff at me. I'm here, please. No? Okay. Has anybody even tried to write any automated unit tests for their database? Anybody?
No, we just check really basic things. Really basic.
Okay. So traditionally people don't unit test their database code, which is a bit strange when you consider that application guys wouldn't even consider writing it nowadays without writing any sort of tests. And actually, when we think about it, the stored procedures may very well actually affect the data in our database. And as I was mentioning before, the data in our database is important. We care about it. So I should probably be testing the stuff that's dealing directly with it. There's probably more case to say that we should be source controlling our stored procedures and our functions than there is to say we should be application the database to, because we don't want to mess this stuff up. In general, what a lot of people do when they're writing software or databases is they'll make some changes, and then there will be a period of checking over those changes to make sure that you've not broken the things that we know break quite often. Well, wouldn't it be better if rather than spending 15 minutes just double checking them, I spent a couple of hours once writing some sort of test that I could automate every single time? That way I know that whenever anybody makes any change to that source code ever again, we're going to trigger that test to run, and if it's broken, we're going to find out about that. That means I only need to do my testing once. Automation is a good thing. It means I can do stuff less often, but the computers will do all the manual hard grind of actually doing it. Use humans for what they're good at, which is coming up with great ideas and ideation and all of that stuff. Use computers for what they're good at, which is following steps and processes. If you've got any checklists, you're doing it wrong. Get a computer to do that. So we want to start thinking about writing unit tests. Now, why haven't we written unit tests in the past? Because there aren't really any tools to do that, maybe? You're wrong. There's open source frameworks like T-SQL-T. Within Visual Studio, there's tooling to write unit tests for a database. And what I'm going to do is I'm going to show you how Redgate has partnered with an open source program to create a really nice unit testing process for the database that we can then automate within our CI process. When we're thinking about, actually I'm probably running a bit short of time, so I'm probably not going to tell you an anecdote about how we at Redgate have managed to get our SQL compare tests from an 8-hour thing that took to run, which meant that we could only get feedback once a day. The code we wrote yesterday, we get that feedback the next day, whether we've broken stuff. We've now managed to get that down to half an hour, which means having spent a few months actually dedicated purely to improving our internal processes, we're now in a position where we can have a lot more confidence in the new features that we write for SQL compare. I won't tell you that anecdote though, because we don't have enough time to see it. However, if you do walk around the office, you might see some nice ambient displays of like random green and red lights that turn green and red, because TeamCity's got like a nice API that you can build on top of, so whenever our tests for TeamCity are complete, you get little green lights, and whenever they fail, you get little red lights. And also the SQL source control and the SQL compare teams are a bit competitive now. They've both got horrible legacy code bases that they've managed to wrangle into submission. They're all green at the moment, or mostly, and their little kind of lights going off to say whether SQL compare is green and source control is green or red, and they get quite competitive about that. It's quite fun. But it's all about enforcing the idea that we want to be making sure that we're writing tests, they're good tests, and they're passing. And that brings me on to the fast test cycles and team discipline. I kind of almost did already tell you that anecdote, but I'll give you the full version later if you want it. So let's talk about how we can do that for the database. Now, I mentioned earlier that this test failed. Redgate has a unit test plugin, a unit test build runner that plugs into Management Studio. I'm not entirely sure I put enough emphasis on that statement. This is a unit test runner inside Management Studio. I can see my test on the left-hand side, I can run my tests, I can watch it running, and I can watch it failing, and it's giving me an error message. I expected to see SQL in the city at redgate.com, but all I got was SQL in the. This is sensible feedback. I'm now finding out that the process ran it, expected to get one result, all I got was another result. So let's go ahead and look at what this was actually trying to do. The visual runner SQL test is built on top of the open source T-SQL-T unit testing framework. This is quite a nice story about a partnership between Redgate and T-SQL-T. A couple of smart guys, Dennis and Sebastian, worked out that unit testing was a thing, and it was a thing the database developers weren't doing, and that they should do it. They started an open source project to write a framework of functions and stored procedures and things that live on your database and that allow you to write effective unit tests and run those unit tests inside the query panes. Now, unfortunately, it's a bit of a dog to use by itself. So they approached Redgate and said, hey, Redgate, you do database development, you do plugins for Management Studio, could you build a really nice GUI front end for us? So we did. We formed a partnership with T-SQL-T. They do the hard stuff underneath, we just write a nice little GUI that goes on top. That's worked really well for both of us. But let's take a little look at what we're actually doing here. So most unit tests follow kind of assemble a scenario, act out some sort of action, and assert that the result of running that action is what you expected. And that's what we're doing here. We are assembling, we're using the fake table command, which is going to create a table that looks in every context like the context table in my database. We're going to carry out the add contact store procedure that I added earlier with the parameter David Atkinson and SQLinthecity@redgate.com. That's an email address with more than 10 characters. And then we're going to declare afterwards that actually the result of running that is that we do actually have the data that we wanted in the table. Nothing particularly controversial there. We're basically just checking that this stored procedure does what I want it to do. It turns out when I run this stored procedure, it doesn't do what I want it to do. It truncates the email address that I'm trying to put into that table, and I can probably think back to a change I made a little while ago that might affect that. I'm going to go ahead and right-click on the add contacts store procedure, which I can script as alter to because SQL prompt is amazing. I can see the offending bit of code. I can go ahead and stick a varchar 30 on that. Let's go ahead and execute that. While I'm at it, I also just wanted to show off the static data feature of SQL source control, because I did mention earlier that we want to be source controlling our static data, so I'm going to show that happening now. So I've made a change to a line of data. Let's go into SQL source control. Oh, I need to actually do that. Let's go ahead and go to the commit tab. Let's go ahead and actually select the correct database.
Is that static data?
There's an option in SQL source control, and I would show it to you, but I'm running behind, so I need to go fairly quickly. There's an option in SQL source control where you can basically just select which tables are static data tables as opposed to transactional tables. I can go ahead and put another useful comment. I can see my data change here, my change to the stored procedure here, and let's go ahead and commit that into source control. Great, it's gone. If I now go into Team City and refresh, as if by magic, in a few moments' time, this will pick up the change and it will start building again. I hope. So there, you can see we've got a pending change, and in a couple of moments' time, it'll start building. Rather than waiting to see that happen, I'm just going to come through and I'm going to show you, oops. I'm going to jump through and I'm going to show you, there you are, it's building now. If we come back to the build steps, SQL CI test. Again, we're inheriting the same database package. The T-SQL-T unit test framework is a bunch of stored procedures and functions and things that live on your database, so that gets committed into source control with everything else. The Redgate deployment tools do all have an option of whether you want to include them in your deployment or not, because, for example, you probably do want the unit testing framework in your dev environment. You may or may not want it in test, depending on how you use it. You probably don't want it on staging or production because it's not needed. So there's a little flag in SQL Compare that allows you to either include it or not include it. But what we're going to do is we're going to build that database completely from scratch. Based on what's in the package, we're going to run our unit tests. Again, the newest version of the TeamCity plugin does allow you to select either all of the tests or a specific subset of the tests. Either it's a specific test or it's a specific class of tests. We can also populate data in the database because we're generating it from scratch. We may want to have some data in there when we run our tests. So we can reference a SQL data generator project, which is going to generate randomized data for us however much we want. And we can run this task as many times as we want. So we might want to run it with a small set of fast running tests to get quick feedback, or we might want to run it with a much more conclusive set of tests that take 8 hours to run. And we might want to do that one overnight because of how we decide to trigger things. We might want to run this in different environments. For example, we might want to run our unit tests in a 2008 environment and a 2012 and a 2014 environment, just to see if we get any interesting results. You can do whatever is appropriate for your release pipeline. This time, when the build goes through, when it's completed, I'm anticipating, we can see that we're running the unit test at the moment. We can actually come through to the build log and see as this is actually happening, which is quite nice. And we can see here that running unit tests, somewhere here it will say that it's passed. Yep, well, we've moved on to the next step now, so we're now moving on to that sync step, so now we're doing that incremental build. We're deploying out to the always up to date with source control database. The reason we do that afterwards is we've decided that we don't want to bother deploying out there if we're failing our tests, because if we're failing the test, let's just stop the line and carry on. Anyway, that's going ahead and doing my nice advanced build with a whole unit test on it. Right, and the build is finished. That was fast. What has gone on to do now is gone on to talk to my release management tool. We're now in a position where not only are we running using source control, so we've got an audit of all the changes, we've got a basic set of builds happening, we're creating release artifacts, and we're testing those artifacts. I get that writing a whole load of unit tests to cover your entire database is not going to happen, because that's a huge amount of work. You need to be doing it as you go. But what you could do is work out what the most important and most fragile parts of your database are and start writing some tests for that. And we've managed to write some sort of unit testing now. We now want to think about how we can make our deployments easier. Now again, we want to be reassuring the DBA, so telling him all about the automated testing that we're doing is a great idea. Telling him all about how he can track back every single change to the developer that made the change, so he can go and sit down with that developer over coffee and in a nice way tell him what he was doing was stupid. Now we want to be taking that release package and deploying it in a standardized way. We've got the state of this package now, so whatever changes have happened on production, when we deploy this, it's going to look exactly like what we've tested. We're going to do that because we've put the scripts folders from source control into that package, and we can use SQL compare logic to work out the diff between them. What we can also do is when we deploy that package, we can also save out the script that we use to deploy that package, so that if we know that I deployed to staging, which is identical to production, then in theory, when I use that script to deploy to production, I'm using a script that I've tested before on this exact state of the database, so if I run it over here, it should work fine. That's actually pretty much the reassurance that most DBAs want. They want to know that you've tested the exact state of the database that we looked at in this scenario. They want to know that I've got an actual script that I can review, and they want to know that you've run the script before and in an identical environment and it's worked fine. And that's what we're going to try and do. I won't go into a huge amount of detail, but yes, automate the whole process, because if you're running this script manually in Management Studio, then you're going to make mistakes. Just because you're going to have highlighted the wrong bits of code, and you don't want to risk that on your production server. We also want to think about our backups. Probably taking a backup before we deploy is a good idea, because no matter how much due diligence you put into it, stuff still goes wrong, and we want to make sure we're protected against that if it's possible for us to take a backup before we deploy. We also want to think about a rollback strategy. I'm not going to talk about rollback strategies now because we don't have anywhere near enough time. It's a whole talk in its own right. Do you roll forward? Do you roll back? Do you take a backup and restore it? There are all sorts of arguments in all the different directions, and there are all sorts of pros and cons for each approach. What I'm going to do now is I'm going to show you how we have automated our deployment process in a semi-automatic shotgun way right up to production. So what this step here does, if you're familiar with Octopus Deploy, it's a tool for taking NuGet packages and deploying them in some way. It was designed for .NET applications, and it handles IIS for you really, really nicely. If I go to the configuration settings here, you'll see that Octopus Deploy has its own build step. I should also mention, by the way, because I work for Redgate, that we also have a tool that does something like this. It's called Deployment Manager, but in the interest of providing a talk that isn't all about Redgate, I wanted to try and show you lots of different providers' tools within this session. And to be honest, you're going to work Octopus Deploy by plugging the Redgate tools into it anyway. So I'm not that bothered, but whether you buy Octopus Deploy with a Redgate plugin or whether you just buy Redgate Deployment Manager, they're working more or less the same way. So that's why I'm showing you Octopus Deploy in this demo. Octopus Deploy is a tool where I can map out all of my environments, I can say where all of my environments are, and I can also automate a set of processes to take the packages that I give to it and define exactly how I'm going to deploy those out. In this case, I'm taking the package for the database and the application. And when I take the database NuGet package, I'm going to copy it across to the target server, including the script file. I'm then going to add a little bit of PowerShell afterwards, which, by the way, you can get that exact same PowerShell by going to my blog, which I showed you on the first slide, which is at workingwithdevs.com. Deploying Redgate database packages with Octopus Deploy. So everything that I'm doing here can be found on this page here, and there's the exact same PowerShell script that I'm using in this demonstration. What that's going to do is it's going to take the package that I've just deployed, it's going to take the scripts in that, and it's going to use the Redgate command line tool, SQL CI. Interestingly, it's exactly the same command line tool that we used under the hood in the Team City project to update a database to look like what's in that package. What we can also wrap around this, if we wanted to do so, is as a command line argument to go ahead and save the script that we generated to a folder somewhere. So for example, when we deploy to our staging environment, save the script off that we use so I can use exactly the same script when I deploy to production. We can hand that off to our DBA instead if we want to. We can also, using Octopus Deploy, put approval gates in here, signing off to kind of sending an email off to a DBA to tell him to come and press the button to approve the deployment if we want to when we're deploying to production. So you really can map out with Octopus Deploy something that is incredibly similar to how most people ideally want to deploy their databases. The difference is that we're just taking the pain out of it, and we're taking the room for error out of it. So we can see that latest is now up to version 2.2.5. That's because we're on build number 2.2.5 for this step here. Octopus Deploy uses a concept of a release. That's because you might have a database and an application and a Windows service and a BI package that are all kind of bounded together. They've all got different version numbers, so you need a version number for the release that contains this particular collection of packages. So we're going to create a release with version 2.2.5, and we're going to automatically deploy it to latest. So this is another environment that I'm automatically deploying to every single time I commit to source control. I can show you that because this is the latest version of our code. That RSS feed that I added up here, look at the column up here on the right. I'm going to actually zoom in here. And I'm going to go ahead and hit F5. There's a SQL CAMS RSS feed that I added into source control a little while ago. And let's go ahead and zoom out. And now I'm going to show you the peak of this demonstration. The staging environment, if we look at it, it's missing a couple of RSS feeds, and also it's got a different header up here in the website. I'm going to go ahead and refresh that. This is exactly how it looks right now. In Octopus Deploy, if I want to deploy the latest version of my code, application and database at the same time, if I want to deploy that to production, it's not quite one click. That was one click already, 2 clicks, 3 clicks.
You said it's to staging now, it's not production.
Same difference. Okay, that was 4 clicks. So it wasn't quite one click, but it's pretty close. And this is going to do everything. This is going to take that package that's come from source control. It's got a complete audit trail back to the developer that made that change. That package has been through a certain amount of testing. We've written unit tests on it to make sure that it does actually comply with what we want it to do. It's exactly the same package that we could have deployed to our previous environments. We've actually got a history of everywhere where it's been deployed before. It's going to deploy the database by using the SQL compare technology to update the target database to look like what was in the artifact. And also, as a Brucey bonus, it's going to completely do our .NET deployment as well and handle all the IIS configuration that we need in order to make that happen. And apparently this will finish in 16 seconds. Any questions at this point? Any questions at all? It's completed. Should we go and see if it's worked? So remember, watch the RSS feeds down here and watch the header up here as I refresh the page. And drink some coffee. I've got some more slides, but I've kind of run out of time. So I guess I'm not really going to have enough time to go through them, unfortunately. So I'm going to try and give you the 1 sentence per slide version of this the rest of this talk. Every delivery is practice. You learn things by getting stuff wrong, but you get good at stuff by doing stuff right over and over and over again. If someone tells you they practice and practice until they get it right, they're doing it wrong, because what they're actually doing is practicing doing it wrong. You need to do stuff right and automate it and do it the right time every single time. That's something that my old violin teacher taught me, hence the picture of the violin. You need to start working together more. DBAs, have access to the source control. Talk to your developers about why they're trying to burn stuff down and why they're doing it wrong. Teach them in a non-condescending way. At the same time, developers, you need to know more about why the DBA puts up these gates and why they're protecting that data. You need to work together more. Think of the Nokia model, where the developers, rather than being rewarded for change, started being rewarded for stability, and the DBA, rather than being rewarded for stability, started being rewarded for change. Everything just suddenly started working so much more smoothly. Project managers, you need to start thinking about operations and thinking about maintainability in the long run. All of those things. I'm sorry, I've run out of time a little bit. Here are some people that are already doing it and having a lot of benefit, who don't mind us telling us about them. The nice thing about the one line about why these are interesting, this is one guy. Even though it's just one developer, people think about source control and CI as being tools for teams, but this tooling allowed him to actually hit his 2-hour deployment window. That was absolutely critical. These guys, horrible legacy database system. They managed to, they're just up the road from us actually in St Ives. They managed to, they invested quite a lot of time in actually refactoring a really horrible code base so that it could work within the SQL source control technology. And now they're in a place where they're actually using CI. They've managed to automate their deployment up as far as their test environment, and they're still working on automating the deployment to production from there. They've already seen massive benefits. Practice Fusion, they're a healthcare company. People think that healthcare companies automating their deployment sounds scary. Well, actually, no, they think that it gives them a lot more reliability. And I mean, you can look at the notes there about the sorts of data that they're holding. They're using Jenkins as a CI server instead of TeamCity. Same difference. It's an automated tool that will just carry out an automated action based on various commits. It's an open source tool. So yeah, in summary, all of the things. Of course, the second one is if you can't do the first one. So there are our goals. I hope we've met them. Stay in touch. They're my contact details. They do come directly through to me. Use them. It is my job to help people set this stuff up. If you want help, if you want advice, I can help you. It's my job. Read some books. The one I'd like to call out is the top one here, The Phoenix Project. It is a novel about IT. I know that sounds daft, but it's brilliant. There are probably a whole load of books that we're all supposed to have read by now, such as 5 Dysfunctions, Lean Startup, Continuous Delivery by Jez Humble and Dave Farley, The Toyota Way. The Goal, which I mentioned on there, which I said I'll bring out, mention at the end. The Phoenix Project does a really, really good job in a few hundred pages of having like a nice, interesting novel with brilliant satirical characters and caricatures of the sorts of people that you tend to see around the office, like the big fat angry DBA and the absolutely terrible marketing person that gives you completely impossible goals. And along the way, there's kind of this Yoda-ish type character who comes along and says, well, you should think about this thing that this guy wrote about in this book. So it's a really good way of giving you a nice overview of a whole load of the important books that have got us to this point. So it gives you a nice high-level overview of all the different books, and then you can decide which one to go ahead and read, whichever one you think is most appropriate to yourself. Also, if you go to redgate.com/delivery, we've got a training academy there. Everything that I've talked about here, we have a whole load of kind of walkthroughs about how to set this stuff up, at the same time as having some advice about general kind of patterns and practices about how do people tend to branch, what are the different strategies for branching and merging, what are the different strategies for setting up various different types of tests and so on. That's where all my images come from. Oh, and also, it was mentioned at the beginning, we are running a training workshop here in about a week where we're going to train you. you get a laptop, it has Jenkins installed on it with no configuration, it has SQL source control and a management studio installed on it with no configuration. And we're going to go through the process of actually setting up the build server using the command line tools to do most of what we've just seen here today, to give you an idea of how to get started. And if you use that promo code, it is free for everybody in this room. And there are still spaces available. So if you want to come along, spend half a day here with me and one of the other more senior pre-sales engineers, we can kind of talk you through the process of actually setting it up for yourself so you know how to do that in your own office. Any questions? Yeah. Any observations or comments?
It's a bit useful. I mean, the thing that always bugs me is that it's the test plan. You know, you have to build every scenario, so you end up just doing manual tests and stuff. But the problem is, it looks quick, it looks fast. It's just the test plan part of it.
Testing is always the hardest bit because,
build every scenario.
I mean,
get that automated.
Working out how on earth to write a complete set of tests that you can be confident in for your entire database. I mean, for most people, it's just a pipe dream. But that doesn't mean that we shouldn't try to invest in the certain parts of the database that we know are fragile, that we know are critically important. And it doesn't mean that we can't start writing unit tests for the work that we're doing now, because that's going to help us in the future.
Do like a demo database, like ones you've already done.
Sorry.
So like a demo database or tutorial database where you've effectively written the unit tests.
There are, if you use the T-SQL2 framework, there's a blogger called SQL Cop. He blogs about general static analysis type things that you can do, like, for example, are there any select stars in your database? Are there any stored procedures that you've named SP underscore, because you shouldn't do that. And he writes, I think there are about 30 different blogs that he's written about all the various things that you shouldn't do and why. And he's written a T-SQL2 unit test to test whether you're guilty of any of those sins. So when you download SQL test for the first time, you can download those basic general tests and you can run them on your own database and give yourself a couple of weeks of homework before you actually start writing your own tests. And so that's quite a nice way to get started.
Do you have any thoughts? Because obviously...
Oh, by the way, I should mention, sorry, I'll come back to the question. We do have a Redgate goodie bag, which has a free license for the SQL Developer Bundle and the automation pack and some books and things in it. And Daniel in the corner, who is actually the product manager, for the automation tools that you've seen there that plug into CI in particular, into CI servers. He's going to award this goodie bag to whoever asks the best question. So sorry, go ahead with the question again.
So obviously you talked about sort of like two sides of the story, like there's the sort of developer side and the sort of DBA ops side. Mm-hmm. What's your experience? What sort of guidance can you give people in terms of getting both of those groups on board with this? Because obviously they can come from two very different angles, and you can achieve success with one but not with both. So, is there any good ways of sort of two groups which might be both quite hostile to this?
Do they sit in the same part of the building? That's a good way to start. Actually get to know each other on a personal level. It's amazing. I mean, we can probably all think of experiences of when there are people that work in different functional teams in your organisation. There are probably some that you just genuinely get on with better than others, and they're probably the people you go to ask to if you've got a question about marketing or sales or HR or whatever it is at your company. So ask them out on your team night outs. Like invite them down the pub after work. Ask them how their kids' football match went at the weekend. Genuinely get to know them at a personal level. That tends to be my advice because I tend to be a fan of kind of empowering the team and doing it letting it work up from the bottom. The other approach is to take the manager of that team out for a steak dinner, and that works quite well too, because top-down leadership works in some organisations better than people at the bottom working together. So judge your organisation a little bit. Work out how changes tend to come about in your organisation. Does it tend to be instructed from the top, or does it tend to come up from the people at the bottom? And get to know whoever those influential people are, get to understand what ticks their buttons, because selling a DBA on the fact that you want to release frequently is always going to be hard until you start working out what they want. What they want is to reduce the risk of deployment. So you can say, if I release frequently and I build a really nice process where you can actually review the changes and see exactly who made the changes and why the changes are good and bad, and I can show you that this deployment has been successful in all these different environments, I can deploy more reliably to you, rather than going in at him with the angle of, I need to iterate quickly so I can get feedback, and I can think about it from their point of view. But the only way to know what their point of view is to get to know them. Literally go, it sounds stupid, but literally organise a meeting with them and ask them, what is your job? What does a good day look like to you and a bad day look like to you? What do you care about? Because they might actually surprise you. And when you ask most people questions like that, they tend to be a little bit flattered and go on rabbiting on about what they like and what they don't like about where they work.
So in an organisation, who typically owns a sort of system or process like this? Is it an individual group, or is it actually those two teams own it together? Is that when it is successful?
So the question that was asked, I've just remembered that for the recording I'm supposed to actually repeat the questions. The question was asked who normally owns this process? Is it the dev team, is it the ops team, and who needs to own it? Well, in the ideal world, you're going to have all the important stakeholders from the entire pipeline in a room together where they can work out where the biggest problem is along the pipeline. Remember what I mentioned at the beginning about the constraint? Where is your constraint? Where is the bottleneck? That's a good place to start. At the same time, start with source control, because everything depends on source control. There are some parts of the process that naturally live with one team or the other. So for example, continuous integration, automated testing, that needs to be something that development teams have got the freedom to do themselves, because that's all about getting feedback to developers. Sometimes you get a DBA messing in because they think that they've got an extra database to look after and manage, but if it's a dev database, they should be content that it doesn't matter if this burns to the ground, because I'll build it again myself. If I, as a developer, start building it and maintaining it myself, I might learn something about maintaining databases. Whereas your production deployment, that is something that your DBA is going to have more say in, because he is ultimately responsible for the production database falling over. But like I say, you do need to be talking across the pipeline. So if you've ever got one silo trying to improve things without the consent of all the other different functional silos, it's never going to end well.
Sorry.
Thanks. So what would be the key reason that you would say and recommend using Redgate tools for unit testing over certain technologies that are maybe integrated with SQL Server? The thing in particular I'm thinking about is policy-based management. So for instance, I could implement various what you could call unit tests against the database, which possibly may or may not fulfill the criteria that you could do with unit testing. What beyond those things that I can do in policy-based management do you think would be the key driver for?
So frankly, I don't actually know enough about policy-based management to answer the question. I guess my response would be, I don't really mind. Just write some unit tests, because at the moment nobody is, and the more people start writing unit tests and thinking about how to unit test a database, the better. The main thing that I tend to, as a Redgate salesperson, the main thing that people tend to talk to me about is using SSDT and Visual Studio and the way that they've implemented some unit testing into there. And my response to that would be that actually a lot of people say it's quite hard to do, and it requires actually writing the tests in C# code, which if you're a database developer is a bit unfamiliar, whereas TSQL lets you write it in SQL code. But I don't happen to know enough about the particular example that you gave.
I'm not sure about the other people here, the sizes, stuff they support, people saying about who owns this process. In our case, is the change man address that owns the process of the whole change control. The problem we have is that people tend to shortcut that change process and make changes as they see fit. For the past couple of months I've been trying in vain to put indexes on a database, which you mentioned earlier, only to find out quite recently that there are already indexes that have been put on by the same company some years ago, which were correctly named, but there's no record whatsoever of where they turned up. And it's you mentioned also there was the DBA puts indexes on and that affects it. You know, these are third-party pieces of software. You know, third-party pieces of software owned by different developers way outside our organisation. They're going to send us an upgrade through. We're going to complain and say the upgrade didn't work because we've got indexes on that they know nothing about, and I knew nothing about as a senior DBA. So, you know, this brings a whole new level of gotchas to the people that bypass the systems that are in place, assuming that they use them.
So that was a really good comment. To summarise it, this is all very well and good if you've got control of the entire pipeline, but if all you get is a handoff from some vendor who provides an update for you, yeah, it's more complicated. It's difficult to have that complete contact across your organisation, across the entire pipeline, if you literally, the people on one half of the pipeline are your vendors, and typically they're going to work their own way and you're not going to be able to influence that. I did have a customer, Jason Coombs, he's on Twitter, Database Jace. He used Redgate's deployment manager. He was given packages that he had to deploy by one of his vendors up 4 or 5 different environments. It took him a day to deploy each database because of the horrible packaging process that they used that involved him opening up zip files and running 15 different SQL scripts in order. And he had to do this every single time he promoted it from each one of his environments, and he had 4 or 5 environments internally. What he managed to do with Deployment Manager is he still had to do the horrible deployment for the first environment. But then after that, he was able to package that up and deploy that across. So at least he knew that he was consistent with what the vendors had provided. And he still had 1 out of 4 deployments in his chain was horrible and manual, but he managed to turn the other 3 from a day-long task into a 5-minute task. So he'd just in an average 5-day week where he spent 4 days deploying and had 1 day to do other stuff, he's now quadrupled the amount of spare time he has to actually do the more proactive stuff that he wants to do. In terms of managing what we call production drift, which is a term that some people know and some people don't, that's where one of your environments has moved away from what's in source control, or what you expect it to be there. So for example, somebody's made a hotfix on production, regardless of whether it was a good thing or a bad thing, it now does not look like what I would expect it to look like based on my kind of application lifecycle management process. We are at the moment working on a tool called SQL Lighthouse, and what SQL Lighthouse does is it watches all of your databases, and it records the state of all of them at that point in time. It creates a SQL compare snapshot, which is a bit like a backup, except it's just a schema and it's a lot smaller, that SQL compare can read. And every single time any of your databases change, we tell you there has been a change that has happened. And we tell you whether it now looks like a state that it's seen before, which is what you would probably expect when you deploy something, because if you deploy something from one environment to the next, we would hope that the result of deploying that is it looks like the previous environment that you deployed it from, or whether it's turned into an environment that looks nothing like anything I've ever seen before. That's the sort of thing that you would expect to see in development because you're doing new work, and you would hope not to see in production because somebody's made a hotfix in production. If you do see that, then it's going to call it out so that you can act on it. It's going to give you the ability to see what the differences is and apply that to your source control or whatever. I'm not promising to have any magic switch to handle relationships between vendors and yourselves. And you want to add the index because the vendor will never add the tiny little index that you want to improve performance, but you need it, and they'll say that you're no longer supported. I'm not going to claim to have a magic switch to all of the problems, but hopefully moving to an approach like this will help minimise or reduce those problems.
So trying to get the concept over the tools such as those offered by Redgate and Quest that are so cost effective in making the DBA's job that much easier, being able to see red screens and yellows on your screen as opposed to rerunning the script to find out that your indexes are out of date or whatever. The higher management just doesn't understand it. Matt and I both learned an enormous amount by coming in this evening about how we can take stuff back and say, well, with change management, he's more up to date than what I am. but it's securing the actual systems, like you say. You wouldn't use that on a prod environment, but it's the prod environment that we would worry about the most, because it's changing on prod environment that gets us into trouble. Found out today that our inverted commas new payroll system that's in the pipeline, the live inverted commas system has got a different temp DB set up to the development and the UAT database. How many months in? 4 months into testing? It's just one of those things that people change things without telling you. Because it's not accepted in the service, it's not on my radar day in, day out, and you just think to yourself, who's doing the testing, and are they getting it right, and why have you changed that but not changed it? So having this quality control just makes things a lot easier.
Please do go and read the Phoenix project. What you'll say, you will read this book and you will say, that's me right there. The CEO of the company or the higher level management just does not respect that IT is something that we need to invest in, because the company relies on it and for all of its business goals. And trying to get managers, senior managers, to understand is really, really difficult. The only advice I've got, a bit like when the developers are talking to the DBAs, or the DBAs are talking to the developers to try and get them to improve their processes, is get to know them, take them out for a steak dinner, understand what makes them tick, and then relate that to why this stuff is important to that. If they care about profitability, explain in exactly those terms why this will make them more profitable. Again, I don't offer to have a magic solution, but getting to understand the people that you're trying to sell to, I'm a sales guy, right? Getting to understand the people that you're trying to sell to helps, and putting it in terms that they can understand.
So you go live. So when they go live with their products, they need your assistance to put them on the live server. You have to slow that down.
It's like even more problematic in like the sort of the modern world of IT, because actually modern world of business, because like the business is calling the shots more and more now. IT has less and less of a say. Business can go out and buy something from a vendor or a cloud service and just say, oh, we don't involve IT, we can just do whatever we want. So it becomes even more dangerous. And they're not interested in making your lives easier, to be brutally frank. They're just interested in will the system do what it can do. So it's about explaining things to them in a language they understand. I was sitting in a meeting yesterday with a customer, and the sort of SQL guy there was trying to explain things to the end users in such a complicated technical way. You could just see their eyes glossing over, and they just were not interested in a single thing the guy was saying, despite the fact it was really valuable, really important about how they're actually encrypting the personal data which they're storing. And actually, but then when you actually rephrase it and talk about what could happen if that data gets out into the wild and they'd be sued and all sorts of that, then they're interested. And it's about communicating in a language which they understand, rather than in some very technical jargon which they just have zero interest in.
That's a really good point, and it's something that I see a lot, especially when I see some of the sales guys at Redgate speaking to some of the technical guys at Redgate or support engineers. A lot of people who are really good at tech aren't the best people at communicating with people that aren't good at tech in a way that they understand.
Nodding behind. Matt represents a different team on the change architecture board, and I've put through various changes to reduce I/O on our NetApp system, selective index rebuilding, and I'll sit there and explain it, and this is the way,
just say best practice.
And all I get at the end of the day, or walk back from the corridor, is just tell them how much it's going to save. End of. Be it hard drive, because too much I/O is going to ruin your hard drive. You're going to have to replace your hard drive. That's going to cost us money.
Well, Frank, at the end of the day, we're all the same, I think. I mean, if somebody comes to you and tries to explain something important to you about why their point of view is important, probably all you're going to pick up on is the IT related things, and you're not really going to understand focus groups and the commercial parts of it, or maybe you will, but a lot of us won't, because that's not what we really care about. So we're all going to perk our ears up when we hear about something that's true and dear to our heart, and so try and work out what is true and dear to their hearts and push those buttons, rather than doing the thing that technical guys do too often, which is just assume a set of knowledge which those people don't have, because they're very, very good.
You're interested in this very specific feature of SQL Server and what it actually means, and they have no interest.
Yeah. The really good people that speak at events, and I'm not one of them, but one of the really, really, really good people are really good at making really complicated things really, really, really easy to understand, and that's what we need to try and do.
Best one I heard was when someone tried to explain what's the new index called? Column store index.
I don't know.
And they tried to explain it in 2012. A new feature, and they were banging on about it, and now it's like 40% increase since 2012. And then the guy went, it's basically instead of going on like it's like that. And you're like, okay, I can understand that. I can live with that. Don't give me any more detail. Just yeah.
I need to make the move. Thank you very much.
That's all right. Thank you guys very much for coming.
Thank you.
Before we do, excuse me, I won't keep you because I want to get a hand as well. For Peter's excluded from this, but we can do if you want. I'm really trying to grow the numbers for this group, so I'm interested in how you heard about the event. You probably did from Peter, but so I'm really interested in where you first Twitter. Okay. Whereabouts on Twitter?
Last one hears about the community event on Twitter.
Yeah. Whereabouts on Twitter though? Are you following someone that? So we've got I signed up to Meetup recently, which you can sign into. Where did you? You were probably on a mail list or something, wasn't you?